Hello, everyone. Thanks so much for joining. And we'll just wait for a few more people to join in and then we'll kick off the webinar. This is called Deploying AI-Driven Personalization Engines. And thanks everyone for joining, taking out time from your day and attending this talk. We have Alex, who is there on the panel and will be helping us out with the webinar today. And you're welcome to try out SingleStore during today's session. And if you like this topic, you're welcome to sign up for future sessions. On October 23rd, we are presenting Beginner's Guide to New RAP Techniques. This is by Professor Tom Ye from University of Colorado and Boulder. So it's these sessions are generally really popular for us. So if any of you are interested, feel free to attend and RSVP right now. And the next day, we are presenting on October 24th, we are presenting Building Secure Scalable Data Access APIs with Hasura and SingleStore. This is a partner webinar, and basically, this was something that was requested on demand by Hasura. So we have put this up, and I hope to see you all there. So if any of you are interested, you can also try out SingleStore during today's session. You will be automatically entered for a chance to win either branded new AirPods Pro or Meta's new Ray-Ban LLM smart glasses. So simply click the link that's present on your screen. I'll be putting everything in the chat as well. So stay tuned for that. Or maybe you can just scan the QR code and it will directly take you to the landing page. I will be putting the link to Alex's notebook in the chat, so you can also refer to that while you're trying to load in your data, or if you just want something to start with. So that's great, and yeah, that's all from my side. And Alex, please take it away. Thank you so much, everyone, for joining.
Great. Yeah. Thanks, Yukti, for the intro. And thanks, everyone, for joining today. Really, really exciting topic coming up, deploying AI-driven personalization engines. Really not too sure of everyone's kind of base skill and knowledge of recommender systems, which is really the topic that we're going to be talking about today. So just wanted to make sure that we kind of all have the same foundation here. What is a recommender system? A recommender system takes in user, event, and product data to generate relevant recommendations. So, this is a very, very high level kind of explanation of what a recommender system is, but recommender systems are kind of ubiquitous. They're everywhere. You see them when you use Amazon to shop for, kind of everyday necessities. You see them on, TikTok and Reels when you're kind of swiping through the feed. You'll see them on Netflix when you're clicking through movies. All of these have users that map to events, right? Clicking on a certain item or buying a certain item or giving a rating to a certain item. And then you also have products, right? And these are very general products. They could be, a toothbrush on Amazon, or like a funny like meme reel that you send to a friend, or a movie that you really like on Netflix, right? This is the kind of the input to what we see as a recommender system. And the output is hopefully relevant recommendations, right? Recommendations that are tailored to you, that are useful to you, that are, things that you would want to interact with, that you want to engage with, right? And there's kind of two high level approaches that most recommender systems take to producing recommendations given user, event, and product data as inputs. The first is collaborative filtering, right? And collaborative filtering is basically where you take users that look similar to your current user and you perform a semantic search to find users that look similar to your current user. And we'll talk a bit about what semantic search means in just a second. But you take that group of similar users and then you look at what those users like in the system, what products they like in the system, given certain event traces, right? So, for example, if you're someone that just clicked on a bunch of horror movies, right? Netflix's recommender system might look at other users that have recently clicked on horror movies and see what they liked, see what they tended to watch for longer periods of time after watching a certain movie, and then it'll try out those movies and try recommending them to you to see if you would like that. So that's kind of collaborative filtering. And then next, there's content-based filtering, which is kind of much more akin to what you would imagine as like a traditional filter-based recommendation system, where, for example, if you're on Netflix and you're looking for a movie and you want a movie that's under an hour and a half, it's horror or thriller, and it was released in the last 5 years. That's content-based filtering, right? So that is exactly matching your recommendations to a specific set of user requirements. Finally, kind of to tie this all together, recommendation systems, both collaborative filtering and content-based filtering, we often require real-time personalization or in-session personalization, right? When you use an underlying database, and we'll talk about the motivations behind this in just a second, when you use an underlying database that's not real time, you will not have as fresh recommendations. Your recommendations may be more stale because you're waiting on data to be queried from your database, right? So kind of prime example of this is an app like TikTok, right? If you're swiping through your feed, you want each and every video to be as relevant as possible. It doesn't work for you to like have to restart the app or to have to wait 10 minutes or 15 minutes in order to get that next relevant video. You kind of want it now, right? You need it in real time. And now we're going to be talking about the library, or the tool really that we're going to be using today in conjunction with SingleStore to really bring all of these concepts to life and to put recommendations into a real world production grade environment. And that's going to be Shape.AI. So for those that are familiar, or those that are curious, that'd like to follow along at home, Shape.AI is a tool, an SDK that makes it really easy to add smart recommendations to your product. It does everything that I just mentioned, content-based filtering and collaborative filtering, and it takes in as input user, event, and product data, and uses machine learning to personalize your user experience, and also allows for real-time personalization, right? Using, of course, the appropriate database with real-time capabilities. So let's talk a bit more about why we might need a real-time database in the first place if we're thinking about recommendation systems, right? So typically in your enterprise environment, right, if you have a database system, it'll look something like this, right? Your end user talks to your application. That might be where your recommendation system sits. Then that application has to talk to, an OLTP database, which talks via ETL to an OLAP database, which also hooks up to a search system. And then maybe from your OLAP database, you batch up your kind of queries to serve, dashboards and analytics, and you dump your data into data warehouses and the like, right? This is supremely inefficient, and it adds, not just latency at every single kind of link you see in this graph. We're adding latency to our end user, right? But also inaccuracy and cost, right? The ETLs can become stale, they can become deprecated, and the data that sits between, or that shifts between your OLTP and OLAP databases and your search, right, has to undergo transformations, has to undergo, has to be piped into certain data lakes through streaming, and all of these systems have to be maintained. They often get out of date, and that leads to inaccuracy. And then all of that, not even to mention the additional costs that you incur from using all of these additional systems, especially if you're using them in a cloud environment. Those of us that have used AWS before will find out, or are very well familiar with, the kind of blow up in costs that you can incur if you use many services, and you're not very efficient about your kind of service provisioning. So that brings us to SingleStore. We believe SingleStore is the best database for modern applications, not just because it supports row-based, columnar, and vector data modalities, right? And also supports those data storage types, but because it works in real time, right? And what do we mean by real time? Real time is in-session personalization for your recommendation system, as opposed to waiting for next session or waiting 15 minutes for queries to be batched to provide the relevant recommendations at that time, right? All of these, so all of your queries will query in milliseconds instead of seconds to minutes. You'll be able to perform millions of inserts per second. So your streaming engines are able to write into SingleStore as fast as you're able to read out of SingleStore. And on top of that, we've supported vectors since 2017, vectors as a data type, a native data type, and vector functions, which allows you to perform semantic search, right? Looking for lookalike users within your database to perform recommendations, right? And just a few more kind of key product capabilities that we've already touched on, fast ingestion via SingleStore pipelines for real-time capabilities, a universal storage type for both row-based and columnar transactions. We not recently, we've had this for a while now, actually. We launched a MongoDB compatible API so that if you use an existing MongoDB app, you can 100 times to 1,000 times speed it up by just switching one toggle inside of SingleStore. Lots and lots of great features that make SingleStore really, really great recommendation database. So let's jump into the demo. I know that we are kind of speeding through this here. I don't know if we have any questions quite yet. Do we have the Q&A open?
No,
We
I
do.
don't. Yeah, so this is just a reminder that you are still in a listen only mode and we don't really take questions by, yeah, like I saw a couple of people raising their hands, so I'm very sorry. We don't take questions like that. Just add your questions using the Zoom Q&A button. It is present at the bottom of your console. So yeah, I'll just
Yes, yes.
care
So
of any
yes,
question
we
and I'll let you know. Okay, thank you.
yes. So we are in a listen only mode. There will be time for Q&A at the end. Sorry, I should have led with that. I'm sure many of you had kind of burning questions while I was giving a very high level overview of what recommendation systems are. Please do use the Q&A function. I will try my very best at the end to get to as many questions as possible, and we do commit to answering all of your questions. If not live via Zoom, then through email afterward. And we will be sharing the slides as well as the code. I believe the code that we're going to be working through today is in the chat. Or Yuki, do you want to share that in the chat? The notebook?
I'm putting it.
Oh, okay, great, thanks. So yes, not to worry. And all of these resources, if you're following along asynchronously, if you're watching the recording afterward, these will all be available to you in the SingleStore spaces as well. Great. So just giving a quick overview of how this demo is going to work. We're going to be showing how to use Shape.AI to work with a very popular data set within recommendation systems called MovieLens. And really at a high level, what we're going to be doing is we're going to be loading that data into SingleStore via SingleStore pipelines. And then we'll be creating a data set inside of Shape.AI. And so creating a data set essentially means allowing Shape to ingest the data from SingleStore. Next, we'll be calling the Shape.AI SDK to actually train a recommender model based on this data set, right? And you'll see it's as simple as one line of code. And then finally, we'll be able to show relevant recommendations in real time. I'll show how that works in the notebook, and then we'll actually move to the full demo, which Shape.AI actually has on their website. It's a great demo. I'd highly recommend that you check it out after this webinar as well. Great. So let's take a look here. So what I want everyone to do before we really kind of get into this here is, before we load any data into SingleStore, obviously we need a SingleStore account. And so if you follow the QR code, I believe, from for the giveaway, or if you go to singlestore.com/cloud trial, you should get to this page, which lets you sign up for SingleStore for free. to get started on our free shared tier. So I'll just show everyone how to do that. If you just click sign up with Google there, it'll prompt you. And what you will do after signing up, obviously I already have an account, but you'll kind of enter in your details there. What you'll do is you will go into your first workspace, right? You'll go to deployments here. It's going to look a little different from what I have here because this is an existing account. But essentially what you're going to do is from this first workspace, you're going to click create workspace, and then you will select the free workspace tier. And then after creating the free workspace, it will also prompt you to create a database to connect to your workspace, right? And then once you have the workspace and the database all spun up and connected, you'll be all set and ready for the next step. It does take a second to actually spin up the workspace. I will just note. So not to worry if you do fall behind as we're kind of going through all the steps here. This is a recorded session and you'll be able to follow along asynchronously as well. Great. So once you have your workspace and a connected database, it should look very much like this. You'll want to go to data ingest, right? And well, actually, let me share out the data set here. And this will be shared out in the, yeah, I just realized that we don't actually have the events data set shared. I will share that as well. Let's just go to sorry, 1 second. It's always what happens with live demos is you don't ever really know what's going to happen until the demo actually happens. But I will be dropping a link in just 30 seconds in the chat to the data set. Oh, okay, well, that doesn't want to upload. Okay, I will upload this to the chat directly. Great. And we'll be sharing this link over GitHub as well. So hopefully everyone can see the events.csv file that we just shared. But going back to the demo here, just going back to the demo here, from data ingest, you'll actually want to go to data sources. Oh, there you go. And after downloading this events.csv file, this is a, just to give everyone kind of a quick overview of what it is, this is a data sets of movie IDs and user IDs from a very popular recommender system test data set called MovieLens. And what it does is it gives the user's a specific user's rating of a movie at a certain time, right? And so what the Shape.AI model, the recommender model, will do is it'll take all of these data points as suggestions, and then it will recommend for a specific user what movies they should watch next. And we'll see how that all happens in just a second. But sorry, that's just a quick side tangent. Once you're in data ingest, you'll want to select the workspace that you create, and your workspace will be under shared tier because it's a free shared tier account. You'll select that workspace, then you'll select the database that you'd like to use. In your case, you'll probably only have one database connected to your shared tier account. And then you'll go ahead and upload. Oops. Go ahead and upload this file here. And then you can also set the table name, and you'll want to note that because you'll need the table name to connect your database to Shape.AI afterward. Then you'll go ahead and upload the file. Oh, and in my case, I actually already uploaded the file. So after you upload the file, what you'll see is in SingleStore pipelines, you'll see the events pipeline created, and you'll see that it is ingesting the data into your database on your free shared tier account. Great. Now, following that, you'll want to go into Data Studio, and you'll want to actually, let's see here. This is the screen that you'll see. From here, you'll want to actually upload the notebook that we've also shared out to get started on working with Shape.AI inside of SingleStore. So what you'll do is you'll import the notebook from this dropdown here, and then you'll have the notebook downloaded, hopefully. And what we have is this notebook, Deploying AI-Driven Personalization Engines, the Python notebook. But in my case, I'm just going to go to the existing notebook. Great. And so once you have this notebook, I want everyone to go to Shape.AI. And that's actually the tool that we're going to be using today to produce relevant recommendations alongside SingleStore in conjunction with SingleStore. What you'll want to do is you want to click Get Started. And I already have a trial account, but to sign up for a free trial account, what you'll want to do is follow their existing signup flow. And then once you're inside their signup flow and you've created your first account, what you'll do is you'll go to the API key, and then you want to get the read and write API key. So once you have access to that, that's what you're actually going to paste inside of your setup cell here. And we'll kind of run through the rest of this notebook because I do know that we will have plenty of questions. But what you'll do is you'll install kind of all the necessary libraries. One thing that I did forget to mention, you'll want to make sure at the top here, it's not set automatically. You want to make sure your connection to your workspace and your database is set, because your notebook does need access to your database in order to provide the necessary connection details to the Shaped SDK so that the Shaped SDK can actually read out of your database. So then you'll initialize your Shaped SDK with your existing API key. And for this data, for this section of the notebook, you actually don't need to follow this because we've actually already inserted the data into our database. This is just if you're interested in extending beyond the Shaped free tier, and you'd like to use all of the entirety of the MovieLens dataset and train a model on the entirety of the dataset as opposed to just a subset of it. In our case, we're just training on the events dataset. Then you'll want to do this, right? And this is just some data engineering code just to reformat the data set into CSV format. And I've already done all this for you so that you can kind of see the events CSV right here. So this is what our events data looks like. It's a little abstract, but essentially, as I mentioned before, it's a collection of users who have rated movies a certain rating at specific times. And we're going to be taking that data to create a recommender model using Shaped. So next, here's the real meat of what we're doing here. We're going to actually be actually reading the data out of the database that we've uploaded the CSV to make Shaped recommendations real-time recommendations. So the way that Shaped actually defines connections to databases is via a YAML file, which is really just a fancy way to format JSON. And so what we're going to be doing is we're going to be parsing out the connection details from the notebook environment. And then after parsing that out, we're actually going to write the YAML schema necessary to connect to the SingleStore database. And following that, we'll actually create the YAML file, and then you'll see how the rest of that happens here. But this is the code that does all of that. Not to worry if you didn't understand, kind of every single moving piece of that. All of this is kind of pre-tested and works for the MovieLens events dataset. For kind of your specific use case, I would highly recommend checking out the Shaped documentation as well as the SingleStore documentation to ensure that kind of everything meshes together for your specific use case. But just for the purposes and scope of today's webinar, we're going to be using the MovieLens events dataset. So you'll see how the dataset configuration is created here. We're kind of passing in the dataset name, the host, the port, the user, the password, kind of all these details that you would need for Shape to actually create a dataset and then train a model on it. And then we write the file. And then next, we actually create the database, the dataset. So what you do here is you run Shape's create dataset. And then after running this previous cell, you should have a file that provides the dataset schema as well as the connection details to Shaped for actually connecting SingleStore to Shaped for real-time recommendations. And so what you do is you'll run this create datasets command here, and you should see this kind of output, which says dataset with name MovieLens events was successfully scheduled for creation. And here is where you'll need to have a little bit of patience, and also is the reason why this is not exactly a live demo today. You'll need to actually train the shaped model, which is based on a collaborative filtering model, right? And this takes some time, obviously. You're training a full machine learning model. And what you'll do is, sorry, this code is a little out of date. But what you'll want to do if you're just training for the events dataset is you'll want to make sure your MovieLens events connector is in your model schema. You'll also have a name for your model. And then you'll also fetch the events data for the model trainer so that the model trainer has access to all of the data, right? And so this is just kind of a SQL query for those of us that are familiar with SQL. This actually grabs the data from the database and allows the model trainer to access the data so that you can actually create the model, right? And so what you'll do is you'll run this create shaped model command, which actually will take quite a few hours. In my case, it took about 2 hours to train the model based on just the events data. And so, we've been talking a lot about real time. In this specific case of training a model, you will not have exact real time recommendations, but what you will get with SingleStore is a real time stream of data into your model pipeline, right? So that into your model ranking pipeline, and we'll see that in just a second. And that actually allows you to provide in-session personalization. So just a few more details. You can kind of check the status of your model as it's training. And then once your model is trained, kind of like in all machine learning use cases, right? There's the first step of training your model, and then you actually run inference on your model. You're actually using the model to provide predictions of the data that you're interested in, right? So Shape actually provides a really convenient way to do a rank command. What you'll do is you'll just provide a user ID, and then given a user ID, you're actually able to see the exact recommendation for that user based on their data in the data set for their next movie that they should watch, and the kind of recommendation score that the model associates with that recommendation. So this is a little abstract, and I want to show everyone how this actually works in practice. And so we'll actually go to the Shaped demo, the movie demo, and we'll show everyone how this actually works. And just a quick disclaimer, this is based on all of the MovieLens data, this demo specifically. It's based on the event, the user, as well as the the product data, sorry. And so you won't get quite a one-to-one representation with the kind of very simple high-level demo model that we just trained. But once you move off of the Shaped free trial and you have access to more than one data set, this is a very feasible demo that you can kind of translate to your specific use case quickly, right? So just looking at the demo here, we've kind of started a new session and we see a number of different movies, right? Let's say we wanted to watch Good Will Hunting, great movie, right? After watching Good Will Hunting, now the recommender model thinks that based on Good Will Hunting, we might like, some of these Star Wars movies and, Godfather Part 2. And you'll see that the results are actually returned in hundreds of milliseconds, right, as opposed to seconds. And this is true in session personalization. Now, if we watch the Godfather movie, right, maybe it kind of understands that maybe we're more interested in classics, right? So it's just 12 Angry Men and One Flew Over the Cuckoo's Nest, right? Some more classic movies that we might be interested in. So just very quickly, you can see how powerful this recommendation model can really get, and how you can really quickly integrate this into your existing use case, right? So we can kind of keep clicking through here. We watch, the Star Wars movie, right? We might get some other recommendations. And then we can also see, for a specific user, right? A specific user ID, the user that we are in this session right now, we can kind of see a bunch of analytics about what what user we're gonna what movies that user might be interested in, some of their attributes, etc. And we can also generate random users and kind of see recommendations for them based on the events data. Great. So we kind of see really quickly how Shaped actually is able to generate recommendations based on the MovieLens dataset connected to SingleStore. And now let's take a few questions. I know that we will probably have a number of different questions, and I want to make sure we have the time for that here. And I do know that we did speed through all of this, so please do feel free to continue to send in your questions here, and we'll try to get to as many of them as we can. Let's see, for some reason, I cannot see these questions.
You can't see the question.
Here we go.
You can?
Okay, yes, I can see the questions. All right. Okay. Okay, so let's see. So we've got a few questions here. One from Sangeeth. What if we don't need to load data in SingleStore? Will you process data at the edge? So that's a very good question. If you don't load the data in SingleStore, I believe Shape does have support for a number of different connectors. But kind of obviously the trade-off that you'll run into there is that some of these connectors are not real time. And so you'll kind of run into staleness and freshness issues with your recommendations. All right, let's see. Mani asks, I missed the first 15 minutes of the presentation. Will we share the recording? Yes, the recording will be shared. Mani also asks, does Shaped explain for each recommendation why it was recommended to the user? So very good question. This is a little outside of the scope of this presentation specifically. I believe that the Shaped model does give a kind of confidence score of the recommendation. And the thing with, kind of recommendation performance and recommender model performance is, and this is really true for, pretty much all of machine learning, is it's going to be very data dependent. And this also touches on another question for Morad, who asks, I'm surprised at these recommendations. They're fast, but they don't necessarily seem to be relevant. That's actually a very good observation. The MovieLens dataset is a testbed dataset used for a lot of recommender system research, right? But it's not necessarily, given how quickly we set up everything, it's not necessarily going to be exactly production grade, right? And so, some of the tips that I'm hoping to give here are, some, learnings that hopefully you can take with you into production. For your recommender models, right? You're going to want to really make sure for your user event data, your user data, your event data, your product data, that your tagging, right, and your rating systems are really very robust, right? And so what I mean by that is, if your rating is maybe just a thumbs up or a thumbs down, and it's not that granular, or maybe it's just 1 to 3 stars or something like that, you might not get as performant recommendation, results, right? As opposed to, having, collecting more data points about specific users, right? Maybe some of their click activity, maybe how long they linger on a specific choice before they actually move on to the next choice, right? All of these kind of concepts are used in production grade recommendation systems that you might not necessarily see in a POC, very fast POC like this, that will kind of be crucial to actually providing relevant recommendations. So there's a reason why, you know, um, there's a whole kind of breadth and corpus of literature about recommender systems. And we're obviously not going to be able to cover all of it in a 1 hour webinar, but hopefully this gives us some direction to how this is done. So Oliver asks, how much training data is required? We have a 1 billion record contacts database with various attributes and technographics on the associated companies. So really good question. 1 billion, wow, that's a really big number. The other part of the equation, right, for training a machine learning model that is, the other part of the equation, other than just quantity of data, right? We talked about quantity of data a little bit, is the quality of your data, right? And so, without knowing specifically what the shape of this, probably monstrous Excel sheet is, and what sorts of attributes that you're collecting, it's really hard to give a specific recommendation. But I will just say, kind of going through and actually looking at your data, looking at the individual rows to see, just from your own intuition, like if you were a machine learning model and you're trying to basically draw the line of best fit through your, data set, right? What sorts of attributes might influence you to, um, fit your curve one way or another, right? What sorts of attributes might give more information to a machine learning model, right? Instead of a thumbs up or thumbs down, like maybe you're also collecting using other analytic or other kind of web-based tracking tools. Maybe you're also collecting, how long a user is hovering their mouse over a specific selection, right? That's a very high signal metric that you can incorporate into, an events data set, right? Obviously, that blows up the size of your data set, and you have to consider the trade-offs of, the cost of training that much bigger model, or the training a model on a much larger data set compared to the additional performance that you get. But kind of just one consideration that you might want to take a look at. So Elaine asks, does SingleStore or Shape come with a native model performance measurement tool or UI? So SingleStore, so just to give a clarification here, SingleStore is a database. And so it doesn't actually run yet the inference for recommender models. We are using SingleStore in conjunction with Shape, which is a recommender model or recommender SDK. It takes in data and also trains models for you and allows you to run inference on these models. So I believe Shape does come with a model performance or kind of model observability tool in its UI. SingleStore is the underlying database that actually stores the dataset data. Great. Subram Subramian, sorry, I just totally butchered your name. He asks, when we try this example, we can skip the data loading part of this code, since we have loaded the data already. So really good question. The answer to that is no. I have already loaded the events data into my specific workspace and database. But when you spin up your free share tier account and you load a CSV into that database, when you first spin up the free share tier account, it will be empty and it will not have the events data that is necessary to pipe into Shaped to actually train your model. And so you'll want to make sure to upload your events CSV following the kind of data ingestion workflow that we just walked through. Let's see. Shaji asks, can you write your own recommender on Shaped from scratch if needed? I.e., if we want to just use the ETL pipeline and some of the web platform interfaces infrastructure. So really, really good question. I believe it is outside of the scope of this webinar. I do think that, and this is just a disclaimer, I don't actually work for Shaped. We are SingleStore, and we're kind of trying to show how to use a real-time database alongside with a recommender SDK. And so Shaped is kind of external to SingleStore. I do believe that you can customize the recommender logic, though I would check the kind of Shape documentation as your kind of source of truth for that. Let's see. Mani also asks, does Shaped give us details about the records it analyzes before it makes recommendations on them? Does it do any behind the scenes enhancements before it makes any recommendations? That is a really, really good question, actually. And it goes back to what we were just talking about, data quality and data quantity, right? Shaped does allow you to inspect your database, your data set. And you can kind of see that. I will show everyone here. Kind of from your Shaped console, you can see your data set, right? And you can click into it here. It is, for some reason, we'll try a different data set. So you can see your data set, right? You can see the ingestion records, data sample of your records, right? But what Shaped does not necessarily do right now is kind of give you a comprehensive look at like how exactly your data should look like for optimal model performance. What that's actually going to take is, kind of the short and hard answer is it's going to take a lot of experimentation. And it's also going to take a lot of data cleaning, right? This goes back to what Oliver talked about, right? With 1 billion records, right? That's a lot of data. I'm sure many of you have, worked with, data sources that, probably get to even that scale or surpass it, right? But again, right, the core driver of your recommender system performance and really all ML system performance is the quality of your data and how wide of a distribution your data kind of covers to match the different use cases of your users, right? And this is kind of abstract, so I'll expand on that a little more. Really what we're doing in recommender systems and machine learning is we're trying to fit a distribution to our data set. And then once we fit a distribution to it, given a new data point, we want to kind of give the best possible prediction, right? Given a user clicking on, a horror movie, we want to give the best possible prediction for the next movies they might want to watch, right? It's possible, right, that, out of all the users that might interact with our platform, we have users that really, really, for some reason, enjoy watching horror movies. And then following that, they really like to have a good laugh. They really like to watch comedy movies, right? That might be represented in your database or in your data set, sorry. It might not, right? The only way that you're really going to know And the only way that you're really even going to know that this kind of subset of users exists is by setting up evaluation benchmarks for your specific recommender systems, doing real world testing, right? You just saw here, we just did some kind of quick clicking through, and already you can kind of see, right? Like based on a lighter model that's more data, less granular with its data. That's based on kind of just a very, kind of brute force like rating metric instead of anything more, kind of high tech than that. You might get some relevant recommendations, but not necessarily everything that you are looking for, right? So you want to think about the subsets of users that exist within your database or within your data set, the different personas that might exist there, right? Maybe you're not even training on data produced by a certain persona, right? Because it's underrepresented in your data set. That's something that you need to consider. But anyway, yeah, that's a very long answer to, really, you just need to look at your data. You need to set up benchmarks. You need to do real world testing. All of these, short and easy to say, but much harder to execute things that will get your recommender system from, just a proof of concept, just, like a demo of a movie recommender system to something that you can actually use, at like Netflix, and that everyday people want to use because it kind of knows them so well, right? I'm sure for all of us, we've used any number of these, feed-based recommender systems like TikTok or Reels or something similar, and you get the eerie feeling, right? Because it collects, because they're so kind of rigorous about collecting the right metrics and cleaning their data and doing, A/B tests in the real world, that they've dialed in the recommender system to kind of almost the level that it feels like the algorithm knows you better than you know yourself. Let's see. Alfred asks, does Shape.AI require a separate subscription or is it bundled in SingleStore? So really good question. So you can get started using both Shaped and SingleStore for 100% free. Shaped has a 7-day free trial, which you can see. This account is a free trial account on Shaped. It only allows, I believe the Shaped free trial only allows for one data set and to train one model on your data set. So it's really, I will say, really only suited for kind of proof of concept ideas and just proving out that, maybe a toy data set from your enterprise works with this recommender system. SingleStore also has a free tier, but it is free forever. And in my opinion, very, very robust. I would highly recommend everyone give the SingleStore free tier a try. The SingleStore free tier database is not just for recommender systems. It's actually what we think is the best database for all modern applications and analytical workloads. Supports up to millions of transactions per second, along with sub hundreds of milliseconds queries on terabytes to petabytes of data. Just as one example, we see with one of our large financial services companies, like one of our large bank customers, we see them performing sub hundreds of milliseconds queries on, I believe, like literally petabytes of data on financial trade data. So we believe SingleStore, for everything from the smallest application to the largest enterprise scales, SingleStore is really the best database that you can use for your application, not just for recommender systems. Great. All right. Let's see. We have a few more questions here, but I'm sure everyone is a little tired of me talking about data quality and cleaning your data and evaluations and that sort of thing. So I will hold off on that just for now. I'll just wait for a few more other questions if they come up. But otherwise, let's see. Okay, let's see. We got a question from Shiran who asks, you showed in the first slide that SingleStore DB fits as an OLAP and OLTP database. Can you share more on that? Any limitations, performance comparison for transactional systems versus analytical systems? Can it be used as a data warehouse? Wow, that is a really good question. And just so I don't kind of hit on this hammer too hard, I will just say for all of these questions, the answer is yes. Um, the single store does work for both OLTP and OLAP. And for those of us that are unfamiliar, OLTP databases traditionally are built for super high throughput writes, right? So the kind of archetypical use case is a bank that needs to support many millions of customers, withdrawing cash and depositing cash, and maybe there's adjustments to your bank account. OLTP databases support this super high throughput of writes to your database. But the trade-off traditionally in database systems is that when you want to actually go and query your data, right? You want to know the average account size, or you want to know the the number of withdrawals over a certain time period. That actually becomes much slower to query because, and this is kind of getting into the nitty gritty of how databases work, is the rows in an OLTP database are actually all grouped together. And so when you go and do an analytical query and you want to look column by column, you have to actually scan through where all the different rows are and aggregate the columns, and that takes a lot of time. On the other hand, the OLAP databases store data by columns, but it's much slower to actually write to an OLAP database, right? These are analytical databases, and what SingleStore is under the hood is it actually supports both row store and column store. Although our column store is what we call our universal storage, and so quick kind of overview of how that works. The row store is kind of best suited for the use cases where you really, really prioritize transactional performance at the cost of a bit of your analytical performance. The single store column store table type, which we call universal storage, is actually a table type that we've done a lot of optimizations on as a columnar table type, right? So super, super fast for analytics, but we've done a lot of optimizations on it so that your transactional performance actually matches or beats many other existing transactional databases. So it's kind of an interesting trade-off here, where if you have really crazy requirements for transactional performance, then you might consider a row store instead, right? But the single store universal storage table type, the column store, supports both transactional and analytical workloads. And we have kind of all the benchmarks on our website, and can also be used as a data warehouse. It actually, under the hood, keeps the kind of most frequently accessed items in memory, and then it goes to SSD, goes to local disk storage, and then finally to like cloud object storage to kind of optimize your costs. So very long-winded answer, I believe, too. Something that I'm a little better versed in, which is database systems as opposed to recommender systems. But great question. Let's see here. I believe we are at just about 5 minutes. Yukti, is there anything that we haven't yet shared, or anything that we should still cover?
No, there's nothing. And if you feel like you want to conclude, we can conclude early as well.
Great. Okay. Yes. I think we can go ahead and do that. If we do get another question in the next few minutes, I'm happy to stay on for a little longer. If there's any burning questions that you have,
You can
or that any of
still
us have.
go through. I mean, there's nothing that is coming in right now. So just to the okay, so we have one question from Sharon. They say that how is it deployed in AWS via Marketplace?
Yes, so you can deploy SingleStore via the AWS Marketplace, as well as just inside of the SingleStore kind of web UI. You can if you kind of walk through the create workspace workflow, which I did not walk through 100%, you will be able to see you can select the different clouds that you'd like to deploy your database on. And we have AWS, GCP, and Microsoft Azure. So we're multi-cloud as well.
All right, that
Okay,
sounds so I mean, just 5 minutes left, and I think we can conclude the session. Thanks for this
sure.
amazing topics. And for anyone that joined late, there's still time to enter for the raffle, and we will announce the winner by the end of the day. The winner will be notified via email, and you can still be eligible to be entered to win. Yes, you will get the recording. I see the question from Subramanian. Yes, this is a very common question that we keep on getting. I feel like I'll start including it in the slides that recording will
Yeah,
be
we
available.
should include in the
Yeah.
slides.
So I'll start doing that. And yeah, so if any of you tries out single store, you'll be entered for a giveaway. You can either get branded new AirPods Pro or Meta's Ray-Ban smart glasses if you have attended today's session and tried out single store with Alex's code. Um, and followed along during during the session. So yeah, stay tuned for that. And if you like today's session, you might like future sessions that are coming up in the next few weeks. Can you please go to that slide, Alex? Oh yeah, awesome. So, a very popular session, we're bringing it back. It's called Beginner's Guide to New RAG Techniques. This is by Dr. Tom Ye. He's from University of Colorado and Boulder, and these sessions are generally they do really well in terms of numbers and questions because basically what he does is that he's teaching about AI, but he doesn't use a computer. He uses his iPad, or I don't know, his tablet and stencil, and he just I don't know what he does, but that's something that's really cool, and it's a very innovative way of teaching coding. Like they actually writes code with his hand, right? So that's very cool. And yeah, and then on 24th October, we have a partner webinar. It's called Building Secure Scalable Data Access APIs with Hasura and SingleStore. So this was a webinar that was requested by them, and we obviously, if our partners are requesting for a webinar, we need to cater to that. So that's there, and it will be amazing content. Please feel free to sign up, and I hope to see you all there. And thanks for attending today's session. Thanks, Alex, for spending so much time taking these questions and preparing the amazing demo. So yeah, and thanks everyone for attending. Have a great rest of the day. If you have any questions, feel free to connect with any of us on LinkedIn and just drop in a message. Any feedback, ideas regarding future sessions are really appreciated. So yeah, I'd like to conclude the session now and have a great rest of the day. Take care, everyone. Bye bye.
Thanks, everyone.